Hello students and viewers, subscribers. There is another problem on frames, sway frames, analyzed by the moment distribution method. This frame was also analyzed by the method of least work and by slope deflection equations. This time, let's just compute, tabulate uh, the moments and compute the moments at the joints and compare answers with the previous methods. So this is a sway frame, and let's assume that swaying is to the right so that it's easy for us to calculate the side sway moments in the second part. So the stiffness of this member, because A and B are expected to have moments at their ends, is just I over L, so 1 over 8. Same is true with CD and with BC. So for BC, the stiffness is 1 over 6, and for CD, 1 over 5. The distribution factor for a fixed end is 0, A and D. The distribution factor for BC is 1 over 8 divided by 1 over 8 plus 1 over 6, and let's make it negative. So that's why we have negative 3 over 7 here. So therefore, for BC, the distribution factor is negative 4 over 7. Remember that the sum of the distribution factor should be equal to 1. Likewise, for CB, it is 1/6 divided by quantity 1/6 plus 1/5. So that's why it is negative 5 over 11 here. So for CD, it is negative 6 over 11. So everything is complete. We just compute for the fixed moment for BC, which is equal to that of CD numerically. So for B, negative 36 square over 12, and that is negative uh, so that's the swaying. Same side sway, delta, delta. Only BC will have no side sway. So again, the distribution factors are as shown. And fixed moment here is negative 90. And here, positive 90. So we begin distributing this unbalanced moment of negative 90 at this joint. So negative 90 times, this is the first phase of the solution. Later on, we'll have to distribute the side sway moments. Then the moment at each joint would be moment at first phase plus moment in the second phase, and times certain ratio, and that certain ratio is solved by statics later. So 51.429 negative 90 times negative 4 over 7, we lock it partially. Negative 90 times negative 3 over 7 is 38.571, lock it partially. Then here, 90 times negative 5 over 11, negative 40.909, lock partially. 90 times negative 6 over 11, negative 49.091, lock partially. Then, since there's no moment on AB, and this is 0, so even if there is moment here, the distributed moment would still be 0, and we're going to carry over that 0 moment here, so there's no moment that should be carried over here. Only from this moment here, distribute on this side. So that's why we have half of 38.571, 19.286, lock partially. Then half, so of course 0 here, I will not write 0. Half of negative 40.909, negative 20.454. I colored it blue because that's the new unbalanced moment. Then half of 51.429 here, 25.714. So if there is moment here times 0, it's still 0. So carry over 0, half of 0, which is here, but I'm not showing it. Only negative 49.091 half to be carried over to joint D, and it is negative 24.546. So we begin again at this joint, negative 20.454 times negative 4 over 7, and that is equal to 11.688 lakh partially. So here times negative 3 over 7, 8.766 lakh partially. 25.714 times negative 5 over 11, negative 11.688 lakh partially. Then 25.714 times negative 6 over 11, negative 4.026 lakh partially. So again, the procedure, half of 8.766, 4.383 lakh partially, half of negative 11.688, negative 5.844, half of 11.688, 5.844, half of negative 14.026 here, negative 7.013. Then negative 5.844 times negative lakh partially. Negative 4 over 7 is 3.339 lakh partially. Negative 5.844 times negative 3 over 11, 2.505 lakh partially. Then 5.844 times negative 5 over 11, negative 2.656 lakh partially. 5.844 times negative 6 over 11, negative 3.188 lakh partially. Then carry over 2.505 half here, lakh partially. Half of negative 2.656, negative 1.328 lakh. Half of 3.339, 1.670. Half of negative 3.188 here, lakh partially. Then negative 1.328 times negative 4 over 7.759 lakh partially, times negative 3 over 11.569 lakh partially. 1.67 times negative 5 over 11, negative 0.759 lakh partially. 1.67 times negative 6 over 11, negative 0.911 lakh partially. Then carry over 0.569 here, half, 0.284 lakh partially. Half of negative 0.759, half of 0.759, half of negative 0.911. Then negative 0.38 times negative 4 over 7 is equal to 0.217 lakh partially. Negative 0.38 times negative 3 over 7, 0.163 lakh partially. 0.38 times negative 5 over 11, negative 0.173 lakh partially. 0.38 times negative 6 over 11, negative 0.207 lakh partially. Then carry over 0.163 half, 0.082 lakh partially, half of negative 0.173, negative 0.086, half of 0.217, 0.108. So we still move on because this value particularly is greater than zero point 0.1. Then half of negative 0.207, negative 0.104 lakh partially. Negative 0.086 times negative 4 over 7, 0.049 lakh, and we lack it finally because this values is less than zero point 0.1 anymore. Then negative 0.086 times negative 3 over 7, 0.037 lakh partially, lakh finally. 0.108 times negative 5 over 11, negative 0.049 lakh finally. 0.108 times negative 6 over 11, then we have negative 0.05459 lakh finally. But before we add these moments, we have to balance the value here so that we have the same moments distributed and carried over. Half of 0.037 is 0.018, then we lack it finally. Half of negative 0.059, negative 0.030 lack finally. So adding these moments, that's the moment in the first space at A. Moment AB is 25.305. Moment BA is 50.611. Moment BC is negative 50.611. The calculations and tabulations are correct. You will be hinted that they are correct if these adjacent values are numerically equal. If they are not equal but close, that's still acceptable, but they should be very, very close. Then adding these column values, 67.482, here negative 67.482, and at D, DC negative 33.743. Let's proceed to the second part, moments due to side sway, then distribute it. So for the sidesway moment for AB, the formula is negative 6EI delta over L square, so negative 6EI delta over 8 square. So that's the sidesway moment in AB, negative 6EI delta over 8 square. Delta is positive because the rotation of the chord AB in our assumption is clockwise. Same is true with CD. And this is, imagine negative 1 over 64, and let's call it negative 25 kilonewton meter. I will explain later why I assume negative 25 kilonewton meter. Then moment due to side sway in CD is negative 6EI delta over 5 square, and I assume it is equal to negative 64. Now these values are, remember the numerator is constant, negative 6EI delta, you may imagine that is 1. I multiplied the side sway moment in AB by the LCD of these denominators, namely 64 and 25. So negative quantity 8 square times 5 square is negative 25. Same is true here. I multiply this by the LCD. 8 square times 5 square. That's why we have negative 64. Actually, you can reduce the moment, side sway moment to AB to negative 12.5, and you make this negative 32. If you make this, if you multiply this by 2, make this negative 50, then you can make this negative 128. As long as the ratio or the value are on the same proportion. So again, the technique is I multiplied this value by the LCD of the LCD of this denominator. So we get that negative 25 and negative 64. So I then apply it here. So we have negative 25 on AB, both ends. And sorry, it's not synchronously uh, animated. I will just explain that later. So we have negative 25 here, negative 25, and negative 64, negative 64. So it's useless to distribute the moment here because the distribution factor is 0 at A and D. So we begin at joints B and C. Negative 25 times negative 3 over 7 is 10.714 lakh partially. Then negative 25 times negative 4 over 7 is 14.286 lakh partially. Negative 64 times negative 6 over 11 is 34.909 lakh partially. Negative 64 times negative 5 over 11, put the value here, 29.091 lakh partially. Then you have to carry over moments. So negative 25 times 0, remember 0, so it's still 0 here, but I will not put 0 there. Only 10.714 half, put it here, 5.357 lakh partially. Half of 29.091, 14.546, half of 14.286 here, 7.143. Then remember negative 64 times 0 is 0, so half 0 supposedly here, but I'm not placing it. Half of 34.909, place it here, lakh partially. Then these are the new unbalanced moment. We begin with this joint 14.546 times negative 4 over 7, negative 8.312 lakh partially. 14.546 times negative 3 over 7, negative 16.234 lakh partially. 7.143 times negative 5 over 11, negative 3.247 lakh partially. 7.140 times negative 6 over 11, negative 3.896 lakh partially. Then carry over, so supposedly it's 0 there, but I'm not showing it. Negative 6.234 divided by 2, put it here, negative 3.117 lakh partially. Half of negative 3.247, negative 1.624, half of negative 8.312, negative 4.156. Then half of negative 3.896, put it here, lakh partially. Then negative 1.624 times negative 4 over 7, 0.928 lakh partially. Negative 1.624 times negative 3 over 7, 0.696 lakh partially. Negative 4.156 times negative 5 over 11, 1.889 lakh partially. Negative 4.156 times negative 6 over 11, 2.267 lakh partially. Then carry over 0.696 half, put it here, lakh partially. Half of 1.889, 0.944, half of 0.928, 0.464, then half of 2.267, 1.134 lakh partially. 0.944 times negative 4 over 7. So it is a repetitive process. I hope that you mastered the process already. 0.944 times negative 4 over 7, negative 0.539 lakh partially. 0.944 times negative 3 over 7, negative 0.405 lakh partially. 0.464 times negative 5 over 11, negative 0.211 lakh partially. 0.464 times negative 6 over 11, negative 0.253 lakh partially. Then carry over half of negative 0.405, negative 0.202 lakh partially. Half of negative 0.211, negative uh, 0.106. Half of negative 0.539, negative 0.270. Then half of, there should be a value here before negative 0.0106. So let's just put it there later because the animation is not synchronized. It retards because of the very large data here. So half negative 0.106 times negative 4 over 7, 0.061 lakh partially. Then negative 0.106 times negative 3 over 7, 0.045 lakh partially. Negative 0.27 times negative 5 over 11, 0.123 lakh partially. Negative 0.27 times negative 6 over 11, 0.147 lakh partially. Then carry over half of 0.405, 0.022 lakh partially. Then half of 0.061, that's the value 0.03, half of 0.123, supposedly before that there's a value here, half of 0.123. So that value is, I'll just continue because it ruins the animation. Let's reveal it first. So these are the reactions, AX, AY, then assume MAB clockwise, MBA clockwise, MDC clockwise, and MCD clockwise. So there's a value here which is half of 0.123, then that is distributed half of 0.123 times negative 4 over 7. That's why we have negative 0.035 there. Then half of 0.123, it should be blue, times negative 3 over 7, it should be negative 0.027. And because these values are already less than zero point 0.1, then carry over half of negative 0.027, negative 0.014. Half of negative 0.016 is negative 0.008. Then we add the moments at A, MAB, second phase, negative 22.606, MBA, negative 20.211, MBC, 20.211. So the calculation is correct. And that's 0.062, by the way. Then adding this column, we have 30.842. Adding these values here, we have negative 30.842. They are equal. So that means the calculations, tabulations are made correct. Then adding this MDC, negative 47.42. So therefore, the moment in AB is 25.305 first phase, then minus 22.606 of R. So that's the moment in AB, 25.305 minus 22.606 R, where R is to be solved by statics later. Then moment BA is 50.611 minus 20.211 R. That's moment BA. Moment BC is negative 50.611 plus 20.211 of R. Then moment CB 67.482 plus 30.842 R. Moment CD is negative 67.482 minus 30.842 of R. And finally, moment DC is negative 33.743 minus 47.42 of R. So by statics, the equation for this is just summation versus x0. So AX plus DX equals 0. I assume that the reactions are all rightward, but definitely because there's no inclined load, they are numerically equal. So considering the free body diagram of AB, summation moment B equals 0. So AX times 8 equals MAB plus MBA. So that makes it easy. So therefore, AX is 1/8 of quantity MAB plus MBA. Likewise, summation moment C equals 0 for CD, dx times 5 equals MDC plus MCD. Therefore, dx is 1/5 of quantity MDC plus MCD, and that is 0. So, substituting the values of MAB, MBA, MDC, MCD from here, so we have 1/8 of quantity 25.305 minus 22.606 R plus 50.611 minus 20.211 R plus 1/5 of quantity 33.7 negative 33.743 minus 47.42 R MDC plus MCD negative 67.482 minus 30.842 R. Then combining values for constants and for R. For the constant, it is negative 10.7555, and for the constant, for the term with R, 1/8 of quantity, negative 32.606, negative 20.211 R, plus 1/5 of quantity, negative 47.42 R, and negative 30.842 R, that's negative 21.0045 of R. From here, we can solve for R, and R is negative 0.51206. Having solved R, we can now compute the final moments into this equation. MAB is 25.305 minus 22.606 of negative 0.51206. And therefore, MAB is equal to 36.881 kilonewton meter as compared to 36.89 something, I think, by slope deflection equation and by method of least torque. Anyway, they are very, very close. MBA 50.611 minus 20.211 of negative 0.51206. So it is equal to 60.960 kilonewton meter. So therefore, MBC is the negative of these values, negative 60.960 kilonewton meter. MCB is 67.482 plus 30.842 of quantity negative 0.51206, and MCB is equal to 51.689 kilonewton meter. Then MCD is the negative of that value, so negative 51.689 kilonewton meter. Finally, MDC, which is MD, negative 33.743 minus 47.42 of negative 0.51206. So MDC is equal to negative 9.461 kilonewton meter. So that's it for this video. It's quite long because really when there is sideway to frames, the solution is really very long because there are two phases of the solution plus the challenge in computing sideway moments.